Hey guys! By the end of this video, you should have all the tiles that you see here on the right hand side, so here they are, with their own collider and their own layer, and you'll also be able to put your mouse over them and highlight. This is going to be quite useful when we select the pieces on the next episode. So without further ado, let's get started. Okay, so here we are with a brand new Unity project. This one is on Unity 2020.1.10. I went ahead and I created myself a new project using the 3D template for the sole purpose that it's a empty template, it's clean, it's something we can start off and build on top of. And that's exactly what we'll do today. So in the preview we saw that we were going to be generating tiles, and that's what we're going to do, but we're also going to enable our project to render using the universal rendering pipeline. So we're going to swap which is the renderer right now. So under Window, Package Manager, we're going to be looking for the universal rendering pipeline. So universal RP, here it is. Let's make sure we install this package. Might take a little bit of time. And I believe that's going to be the only package we'll need until we reach the multiplayer part of this tutorial. Now for the moment, the universal RP is enough. Let's click this off and let's start setting up our pipeline. So in a new folder that I call config, I'll create myself a new rendering pipeline and a pipeline asset. I'll just call this, actually I'll leave it the name it is right now. So just hit enter. And here we have it on the right hand side in my inspector. I can now go assign it by going under edit, project settings, and then graphics, and we can click on this little icon here and find our pipeline. Now with this, our project is ready to go, and we are going to start right into the code as we like to do. So I'm going to create myself a new scripts folder, and in there I'll create a new C# script, chessboard. This is going to contain a lot of logic. This is going to be the biggest script in our whole game, so we're going to try and make sure we keep it clean right off the get-go by just getting rid of everything. And when I say the biggest script, we're talking about roughly 600 lines if I recall. But don't worry, because we'll be writing that gradually over the next couple of episodes. And 600 line is by the end of the section number 2. So before we do multiplayer, but then after we've done all these special moves. Okay, so the first thing we'll need is an awake. Why an awake? Because we need to have a certain point in time where we start firing our code. And some action that need to be done when we fire our code initially is to first generate the floor, right? Generate where the pieces are going to be going from one place to another. So we will be doing that today. We're going to be generating our board, basically. And what I'm going to be doing a little bit later on as well is I'm going to go grab some assets, some art asset to the asset to match what we're going to be creating. But don't worry, you don't actually need those assets. You'll see we're actually going to put a material on the tile. You can change that to whatever you want. But in my case, I'll be putting it on transparent because I'll have some assets in the background. But as we get through that, you're going to see exactly what I'm talking about. But right now, let's go back to the tiles. And we'll start off by creating ourselves a function that we'll call from the awake, but I'm just going to start creating it first here, called generate all tiles or generate grid. So what I'm trying to create basically is where the pieces are going to be moving. I'm going to be taking in a couple of values in here. First, a float for what is the size of a tile. Knowing that it's square, it's going to be the same value on both sides. So I'll say tile size. And then how many of those tiles do we need? Since we're doing chess, then we're thinking about 8 by 8. But let's just call it tile count X and then tile count Y. Okay. It's going to be wrapping up this function here, and we'll call it directly from the awake. Right now, we don't exactly know what the tile size are, unless you don't have art, right? So if you don't have art, just define that. If you want to have your tile 1 meter by 1 meter, that's going to be simple. In my case, I'm going to be matching it to whatever the art is. But for the moment, let's do a single meter. For the tile count, we'll need 8 by 8. And actually, you know what? We're going to be keeping those values here at the top. So as we go through the script, as we make it, we're going to be declaring field at the very top. And I'll try my best to split them apart. Like here, those are logic field, and a little bit later on, we're going to have a field to adjust with the art. But let's just start with the logic field, which we could input the tile count. So I'll do a private cons tile count is equal to height. We could do tile count x like so, and do the exact same thing for the y. I'm putting them in capital. Oh, actually, sorry, int. I'm putting them in capital because those are constant value and they never change, so that's how I like to define my constant. Now, as far as style goes, it's going to be very simple. We're going to be creating a new game object, and we're going to be creating the mesh inside of it as well. So I'm not thinking about using a prefab. I'm not thinking about using a primitive directly from Unity. Instead, we'll be creating our own empty game object, and then we'll create a mesh inside of it. So to do that, we're going to need to keep track of those game objects that we'll be creating. So under the logic field, I'll create myself a game object two-dimensional array, and that's how we do that in C#. So you just do the array sign and put the comma in between. That's for 2 dimension, that's 3, and so on. And we'll call this one tiles. As simple as that. I could be creating it right here, but I don't think I will, for the sole purpose that we might have different tile count. So what we'll do is we'll take this array and we'll generate it right here. Let's say this one is a new array of tile count x and tile count y. Now all we have to do is go through tile count x and also tile count y in a for loop, in a 2-level for loop, and then just populate every single one of these fields one by one. So if I double tap on tab while I have the for highlighted, it just creates the whole loop like that, and that's what I want to do. We'll do x as long as this is smaller than tile count x. Same thing down here, but this time with y. And I'll be removing these brackets because I usually don't keep those when it's a single operation. And inside of that operation, we'll do tiles at the index xy is going to be equal to, and now is where we have to create that tile. We're going to be doing that in a separate function called generate single tile. And that new function is going to take in the tile size, so how big it's supposed to be. Also, where is it exactly right now, so x and y. We can now go down here, or we could also, I believe, hit control dot and generate a method for that. Yep, it just did it here. So we're returning game object, generate tile size, x and y. That's perfect. That's exactly the way we would have named it anyway. Now this is where it gets a little bit tricky, because we have to create our game object, which is quite simple, right? So we can do game object, tile object is equal to a new game object. We can send in a name, so we can say, for example, just so we can see it better in the inspector, we can say string format and then do something of the sort. And then send in x and y as parameter. Now this way it's going to create a new tile under the scene, which maybe we don't want. Instead, let's actually send our new game object as part of the chessboard object. So here's what we'll do. Tile object dot parent dot transform, sorry, dot parent is equal to transform. This is the chessboard transform. So when we apply that to a certain piece of art, 3D art, or we just leave it as the empty game object, all the tile we're going to be generating are going to go beneath that, and if we move it, the tiles will also move. So that's exactly what we wish to do here. And let's just do return tile object. Now obviously that's not enough, but let's give it a try. Let's just make sure we see if this works by putting it directly in the scene. I'll call this one chessboard. We'll drag and drop this object and hit play. Now as you can see, if you open up this chessboard, you'll see all the new tiles being created. So here they are, but there is nothing inside of it. So there is no mesh renderer, there's no information whatsoever about what they are, and so on. So that's what we're gonna have to create right now, right here. So in order to render a 3D object in Unity, we need two things. We need a mesh filter that contains a mesh, and also a mesh renderer that is gonna take care of rendering the mesh. So we are gonna get started by first creating ourselves just a mesh object. And we can do so by just saying is equal to a new mesh, right? So we just declare it like that, no value in it, that's totally fine. And then we can add a new component, and that component is gonna be the mesh filter. That's something we'll need. And we'll also need to assign the mesh inside of it to the new mesh we just created. And since we can do that on the same line, let's go ahead and do it. I'm going to say the mesh filter mesh is equal to the new one. so the one we just created. And then let's also add, right after, let's add the mesh renderer, like so. And just by creating that, we should have a empty material that we'll fix in a bit. But right now, let's just take care of this. And the hardest part here is to actually generate the geometry. And to do so, we're going to need to define a bunch of things. So a list of vertex. Technically, we only need 4 because we're only generating a single tile right now. We're also going to need a list of triangles, and I think that's it actually. Yeah, let's go ahead and make that code. So we're going to start off by an array of vector 3 that are going to be our vertices. Those are going to be the, you could say the edges, the vertex of that. So let's generate a new vector array. We need 4 because we have only 4 corners for that square, for that shape we're creating. And then we're going to create it, create every single one of these one by one. So we're going to say vertices at the index 0 is going to be equal to, and now this is where we have to place it properly. So knowing that we have to move it every time that we go from a different x, different y, you know, there's a certain offset, we're going to start by adding that variable offset in there. So y times the size, so tile size, and that should be enough for the first one. In terms of the y-axis, I'm going to leave everything on the 0 right now. That's the height. And then finally, let's do y time tile size. That's going to be our verse 1, a very simple one. But then after that, we're going to create a new vertex at the index 1, and we're going to say it's actually y plus 1 this time. And you probably understood what we're about to do. Same thing on this side, it's actually x plus 1. And here we leave it just on normal y. And then finally, both of them at the same time. And with this, we should be able to have a vertex in every single one of the corner of the square. Alright, next up is the triangle array, which I'll just define real quick. We have to define in which order our triangle are being rendered. So it's 0, 1, 2, 1, 3, 2. If this end up not working for you, it's because we have a different order. Because if you define these vertices in a different order than I did, so for example, oh, here I have a typo. For example, you had this here on index 2 instead of at index 3, then you would be rendering in a different manner. You have to render your triangle in the proper manner. So here, this triangle index is actually referring to the vertices. So it tries to create a triangle this way. So by going at 0, 1, 2, so from this one to that one to that one, and then it creates the other triangle with 1, 3, and 2, which end up being both sides. Okay, that should be enough. Now it's time for us to assign them. So vertices is equal to the vertices we created, mesh the triangle equal to the triangle, and we're pretty much good. Alright, we're gonna need to come back here in just a little bit. Actually, you know what, let's do it right away. So a little bit later on, we'll need to have a collider as well to do the raycast. So we're just gonna do it right now by saying tile object add component type of box collider. Why am I using a box collider instead of a plane? It's actually because it's more efficient. There's no other reason than that, actually. Boring answer, I know. Let's have a look at this. And here they are. So we have a bunch of tile, as you can see. When I click on them, you can see that they are actually separate because of the colliders. So I'm glad I added that now. And the pivot point is in the center, which is going to help us a little bit later on. Okay, but definitely this does not look very good. So we'll need to add a material and actually assign that material as well. So to add a material to our tile, we are going to head at the very top here of our chessboard, and we'll declare a new section for everything art related. And I'll do so in a certain header like this. So art stuff, right? And by creating a header, we'll be able to see that in a different section under our inspector. And we'll start with a serialized field, could be public as well, that I'll just call material, tile material. As simple as that. And then we'll take this tile material, go back to where we actually create our mesh renderer. And just like we did above, we'll do a 2 hit and 1 stone. We are actually going to assign the material as we create the mesh render. So dot material, tile material. And I believe that should be enough to give us... Did I assign material? I did not assign a material, so that's not enough. Let's create a new folder called materials. And under here, I'll create a new material called tile. Or actually, you know what? I'll call it transparent tiles. Just for me, for the sole purpose that I'll be having art on top of that, as I've mentioned earlier. So right now, I'll just leave it on where it is, so it's a white object, and I'll drag and drop this right here, and hit play. And we end up with this. So it's actually a blackboard, but I do have a light so for some reason I get to have some weird stuff here and weird looking effect on my board. And that's because we created our mesh, but we never actually assigned the normal. So what we're gonna do is go back here and just beneath everything, we're gonna say recalculate normals. And by doing so, the light should be calculated properly on top of my mesh. And here it is. Good. So with this done, we should now be done with generating the tiles. Fairly simple operation. The next operation is going to have to do with highlighting the tiles when we mouse over it. So what I'd like to do is first start by doing the raycast, and by changing the layer of the object I'm actually highlighting. And by doing so, we're going to be able to use the universal rendering pipeline to have a different render on top of a single tile. So to do so, we are going to open up the script. And here we have everything regarding generating tiles. So I'm actually going to put that under a small little section here called generate the board. Now under my awake, I'll do a update. The reason I'm putting them together is because both of them are coming from mono behavior. Now bear with me, because this update function is eventually going to be quite big. Maybe not this episode, but eventually it's going to be quite big and quite complex. So we're going to go step by step, make sure we comment everything so when we go back we understand. And the first thing we'll do is actually look if we have a current camera. If we do not have a current camera, so make sure you put the negate sign in front of it. If we don't have one, let's actually assign the current camera to it. So camera.current, and then let's hit return in case it doesn't work. It doesn't matter, we'll have it on the next update frame, right? So let's do that first. Now right after, we're going to go ahead and create our raycast. And I'm going to start by creating a raycast hit that I'll call info. And then beneath that, I'll just create the ray itself, right? For two reasons, we'll need it in two cases. So first, let's do ray is equal to, we use our camera, so current camera, screen point to ray. And we send in the input.mouse position. Now with this, we should be able to have a ray. Is that working? Oh, actually, I need a screen point to ray and not screen world to point. So we're gonna go ahead and declare our raycast. So physics.raycast. We're gonna send the ray we just created. I believe the overload we need has the out info right here, and then the max distance. I'm gonna input 100, but just make sure you input a number that is big enough so when your camera is not too far away basically. But it's really important that you do input a number, because you need to make sure your ray is not infinite. If it's infinite and you have a big scene, it's gonna be quite expensive basically. And then here we'll need some layer mask. Of course, you'd like to just limit the interaction you have with only the chessboard itself, so we'll need a separate layer for that. I'm gonna do layer mask dot get mask for everything that is called tiles, or just tile like that. Which also mean that we're gonna have to go put our tile that we had earlier, we're gonna have to put their layer on this as well. So to do so, I'm gonna go in the generate single tile, and here, somewhere at the end here, I'll say tile object dot layer is gonna be equal to layer mask dot name to layer. I'm not using the same thing as I did earlier, so I'm not using a get mask. Get mask is cool because you can have multiple layer here, but you can only assign a single layer to an object. So here I do name to layer tile. Now you understood that this does not exist right now. We'll have to create it in a second. And why not do it now? So let's go back. I'm gonna go under the layer here, add a new one called tile. Hit enter. I don't need to assign it anywhere because when I start a game under the generate tile, single tile, as you can see here, it assigned it automatically upon creation. So all of these now belong under the tile layer. Okay, so if we manage to hit something with our raycast, the first thing I need to know is which tile did I hit, basically. And I can do so by actually going through the list that I had earlier, this list of tile here, and matching the game object. And it's an operation that we'll be doing maybe a couple of times in the future as well. So I'll create a helper function for it that I'll just put down here in a section I'll call operation. And here's what I'll do. Instead of returning the actual tile object, I'm more interested in knowing what is the index of X and also Y. So later on when I do a move with, for example, a chess piece, I get to know the index of the tile instead of the actual game object itself. So what I like to return is actually a vector2 int. A vector2 int is just like a vector2, but instead of having float values, you have int values, which that means you can put them under arrays and they work, right? Because you can't put 0.5 in an array, as an index at least. So I'll call this one lookup tile index. And we'll need a game object that I'll just call hit info, because that's what it is, right? It's the information we get from the raycast. Now, I'm going to be taking this here, and I'm going to say vector2 int the hit position is going to be equal to lookup tile index at info.collider.gameObject. I can't access the collider, the game object right away because we don't have access to that type here. I can do transform, however, and maybe transform is a little bit less expensive than getting the collider. So the role of this function is going to be to get the indexes of the tile I've hit, and now we have to create that function, which should be quite easy. So we just iterate through the list of tiles we have and we look if it's a match with hit info. So let's go ahead and do that. So for loop, I'm going to be changing the I for X. I'm going to be changing the other I for Y in this case. And we're going to say tile count Y. As I've mentioned earlier, since I'm only going to be doing a single operation here, which is going to be to look for that. So if tiles at the index X, Y is equal to hit info, then we're going to return a new vector2 with these two values, so X and Y. Else, if we don't get anything, if we don't get any match, which should not happen, but just in case it happens, let's return something that is invalid so we know it shouldn't work, right? We're going to do minus vector2 dot 1, and it's going to return something like this instead, which is going to break our whole game, because if we're trying to access certain places or certain tiles with the index -1, then everything's going to go out of bound and crash. So this one should not happen. This is actually an invalid, but I don't think we're ever going to get here because our tiles are being generated and all are being populated as well. Okay. Alright, so once we have this information about the index we've hit, we're going to be storing that somewhere here locally. So I'll create myself a new vector2 int, and I'll call it current hover, which is the place I'm currently hovering with my mouse. And we'll assign it down here. But do note that, this is being called every frame, so what gets to happen here is if we just assign it here at the top without checking with the last value, we will not know if we go from one tile to another, because if you go on a single tile and then you move to another tile, we need to check if there's a difference, right? Because the hit position is going to be different. If that's the case, we need to reset the first tile we were on, reset that to a certain color, and move on, right? So here's what we'll do. We'll start by checking if the current hover, so the one we had earlier, is not equal, or is equal to minus vector2 int.1, which is going to be a value I'll use when we don't have any hover, right? So when we're on default, nothing is hovering, we're going to be using this value. And if that's the case, it means that we have to assign it. So first time hovering, it's not really the first time hovering, but then we went from not having a hovering target to having one. So we can say current hover is equal to hit position, and also change the tile of this one. So tile hit position.x, hit position.y, And those are all game objects. You can go ahead and say layer, and let's do layer mask, name to layer, and change that to hover. And by this, we should now be able to, so I'm going to say something here. If we're hovering a tile after not hovering any tile, then we do this. However, if we were already hovering a tile, change the previous one, and so on, right? So here's what I'll do. I'll just copy this over and I'll say if it's not equal to the hit position, so if the value we had prior on the last frame is not equal to the new value we're getting now, it means that first we need to take this current hover and change it back to what it was. So here I'll copy this over, I'll say tile at the index current hover.x, hit position.y, layer, and it's going to be equal to layer tile. So that's going to be our bland boring layer, and that's going to be the one that has the highlight on it. And then we can say current hover is equal to the hit position, and just go back to what we did earlier. Okay, so that works well until we actually exit the board. So for example, if we are getting this, but then after that we're exiting the board, so on the next frame our cursor is outside of the board, then we need to do something in the else statement of that raycast. And we will do so by first checking, do we have anything we're hovering right now, right? So that's also why we kept the value inside of this. So if current hover, make sure my face is not in the zone, yep. If current hover here, if it's not equal to minus vector2 int.1, so if it's not equal to the value I'm supposed to be putting it on, then I'm going to first say, well, now it is equal to that, right? But before I do, let's make sure we reset the tile, just with the same exact line we've did it above here. So current x, current y, and change it back to tile. And with this, we should now have everything we need for our update function in order to only change the layer right now. We're not changing the material on top of it, we're not changing the look of it, and that's totally fine. We'll do that in another way. But let's take this camera. I just want to take this camera real quick and just center it here, make sure it looks in that direction so I can just see the board, right? Not a very good way to see the board, but here, this one over here at 0, 0 has the layer tile, and if I am to mouse over it, nothing happens here. And here we get some problem here with a game object that can only be on a single layer. So let's have a look where this is. Oh, name to layer hover does not exist. I forgot about that. So let's go back, create ourselves a new layer, call this one hover, and press on play again. And as I hover this tile, still not getting anything. Okay, so after debugging quite a bit, I realized that there's a bug in here that I need to mention. So I reverted back the code to everything that we saw together. The only difference now is that instead of using the camera.current, I'm going to be using camera.main. So camera.current actually dropped the reference quite a lot, and I would have multiple frames in which I didn't have a raycast, so I didn't even process the whole update. Took me a little bit of time to figure out, but right now this is not a reliable thing for me, so I'm going to go back to using camera.main. And as you can see, I'm going to highlight this over here, so this 0, 0, and I'm going to put my cursor over it. And as you can see now, it has the hover layer. However, our material is not being overwritten, which I don't know why, but we'll give it a look how we can fix that now. So I'll just manually put that on hover, and I'll go over to my material. Here it is, it's supposed to be red. Go on my pipeline asset, and maybe I need to do it after rendering transparent or opaque. Actually, here it is. So okay, all right, so here's my current problem. The material I'm using for the tiles is actually not on the transparent layer. So what was happening earlier is I was on transparent over here, and they're not on the same queue. So I rendered this one first, and then I tried to render the other one using the transparent queue. It did not override So here's what I'll do, because I know that I want to have some transparency on top of this very specific one, the back of the board, this board. Since I know I want to have this, I'm going to put it on transparent. So eventually I can lower down the alpha. And the hover tile is also on transparent. I'm going to go ahead now and go back under my render pipeline, make sure we're on transparent, and that I am rendering after transparent. There it is. Okay, took a little bit of time, but we got it. And now as I move around this, I should be able to highlight my tiles, as you can see. And it seems to work. Alright, so now we reach a point in the first episode where it's optional to keep going. Simply because I'm going to be using assets from the asset store, and of course you don't have to buy them if you don't want to. In my case, it's going to be very useful because I want to be able to see things and I want to have different pieces. Now, of course, if you're not to buy something like this, you might want to create different primitive or have somebody else make assets for you just to see the difference in between the pieces. Let me give you an example. This is the pack I'll be buying. It's actually from one of my friends, so it's a win-win in this case. And every single piece is different. They also have a different color. So I'll be using this and also the board beneath it to include in my game. So I'm going to go ahead and just put that link in the description down below. Do note that I'll also put my affiliate link, so if you want to buy that, it helps me out just a tiny bit. So it helps me and my friend out, which is it's a win-win. Yeah. And then once we have these assets, that's not the only thing we'll do. We'll also add code to make sure that if you have your own asset, if you are to integrate your own asset, you'll be able to tweak a couple of settings and have it work with your asset as well. Because we need to match the tile size, we need to match the center of the board if it has a different pivot point and things like that. Once you import the asset, it's actually going to come in a folder called artworks, and inside the artworks is everything the package has. So you'll find bishop, chessboard, king, knight, and so on. I'm going to go ahead and drag and drop the chessboard. Now I want you to see, it's a modification I've done, but I want you to see that I've actually changed the scale factor here to be on +10. So all of these were a little bit too small for me. Therefore, I've made sure to put the scale factor on 10 and press on apply down below on every single one of these objects. You can also do multi-editing if you wish. Okay. And I'm going to be putting this chessboard here in the middle. I'm going to leave the material that's on top of it. And I'm going to delete the old one I have here. Actually, you don't need to delete it anymore. You can just grab the component and drag and drop it on top of the new object. And then delete the old object. And now I have my piece of art actually has the script on it. And if we press play, here's what you'll be able to see. So definitely we are quite off and we need to figure this thing out. So in the way we render things, and also in the way we generate our tiles, we're going to have to change a couple of things. So let's go ahead and open up our script. And now under the art stuff section, I'm going to add a new float for tile size. I'm going to default that on 1. That's what we had earlier. And in case you forget to assign this and it's on 0, you won't see anything. You might think it's a bug. So it's a good thing to actually put a default value in this case. I'm going to have another float, this one for the Y offset, because we want to be able to spawn just a little bit above, let's do 0.2 in this case. We'll have to change that. We'll have to adjust that actually. Next up, we're going to have a board center. Right now I put it on 0, but it's just a vector 3 to rearrange in case we have a different pivot point. And finally, we'll do one more thing, but this time we're not going to put it under the art stuff. We'll put it under here, under the logic, and it's not going to be a serializable field. It's going to be a vector 3 called bounds. And this one will tell us how far away is the extent of our chessboard. That's going to be useful for generating the tiles, but also for placing the pieces later on. And we're going to go down in the, where could we go first? On the generate all tiles right here. We're going to start by taking the actual Y offset. So what we have right now as an offset, which maybe like the board is that big and we say, okay, we have to spawn above that. So our pieces are on top and not within the board. Yes, we already have that. We're going to say plus equal the transform position.y. In case in the world space, we actually lift our board as well at the beginning. We need to spawn our thing at the proper place. So this is what it's there for. We're going to start by doing that. And then we are going to define the bounds, and we'll do it this way. We'll start by doing a new vector 3, and we'll take half of the tile, because we know it's 4 on one side, 4 on the other side. We just want to have like the extent on one side. we're gonna say 4 divided, actually 8 divided by 2, so we have 4 times the size of our tile, depending on what they are. And then we'll do it exactly on the same side as well, so we have the extent on the top right. But then on top of that, we'll also add the board center, which just happens to be 0 in our case here, because the asset we've downloaded from the asset store has a pivot point that is directly in the center of the board. But if that wasn't the case, we'd have to adjust it with the board center value. Now, the last thing we need to do is actually these two new value that we have right here, actually 3 new value with the board center, but this one is integrated within bounds. We have to add them down below here in our vertices. So when we do a new vector 3, we assign this position, but then we do minus bounds on every single one of them. And for the Y, we're going to be using the Y offset, not yo, okay, Y offset, like so. Okay. Now, once we launch this, we should have something that is a little bit more appropriate, but maybe not perfect just yet. Okay, so at least it's on top of the board. The only issue here is, of course, that we don't see the board. Reason being, these tiles are 1 in length, and as you can see, the tiles in the art are definitely not 1 in length. So I believe in this case, because I did the math prior, I actually tested it out. I believe those are 0.7, so I'm going to put my tile size on 0.7, hit play, and this is what we end up with. So is that, where are my tiles? It's a little bit too big. Did I actually, oh I know, I didn't change at the beginning here under my wake. So my problem right here is that I didn't change the generate all tile hardcode we had earlier, so we're going to put that on tile size. Okay, this is also a value we're going to need in the next episode, so if you have skipped this, I'm going to have to talk about it again on the next episode, but that's totally fine. It's a small value. Alright, that being said, we now have this board on top of the board. And maybe now you understand why I wanted to have transparent tile. It's so I could actually see what's beneath that. And maybe we need to adjust our offset just a tiny bit, because it seems to be a bit high here. So I'm going to lower the offset, the Y offset, to 1.5 and see if there's still some spacing in between. Yeah, and it seems to be good spacing. It's just enough for me. Okay. And to turn these tiles into transparent one, I have the option to create myself a new shader under my shader folder that I just made a second ago. Or, for the moment, let's keep it simple, and let's just go under the transparent tile and turn our blending mode to multiply. Since there's nothing to multiply with, it's just gonna look like this. And now I can go back in my game. If I move my camera just a tiny bit, like for example like this, I can highlight all the tiles one by one by going over them. And that's actually where we're going to be wrapping up this first episode. In just a bit, let's make sure we have some proper placement of the camera. So I'm gonna align this with the board and maybe have an angle that is able to view the whole thing. So something like that. I'm seeing 65, roughly 65 on the x-axis for the rotation. And we end up with something like this. Alright, I'm also going to change the hover color to a white one, so it's a little bit less aggressive. And that's actually where we're going to be wrapping up this very first episode of the chess tutorial. So if you could please drop me a like and also a subscription. Subscriptions are free, just hit the red button below the video. In roughly 500 subscription, which should not take that long, right? But in roughly 500, we are going to release some more tutorial about this chess. We're going to go beyond just creating the whole chess game, the first part. We're going to be doing the second part, in which we do special moves such as castling, en passant, and promotion. Things that are in chess, basically, but maybe are less beginner friendly, you could say. So we're going to be doing that, and then once we reach 10,000 subscribers, we're going to be taking this chess game here and make it multiplayer and host it somewhere. So that being said, make sure you share this around with your friend, and thank you so much for watching. I'll see you soon. Cheers.